So what we're going to do is we're going to do a very cool reaction. Again, from yesterday you saw me do the gummy bear demonstration. Okay, clearly that was a lot of fun reaction there as the disaccharide reacted with the potassium, well actually the oxygen that was released from the potassium chlorate. And today we're going to do a much cooler reaction. So if you like this might be something for you to pay attention to. What I'm going to do is I'm going to add these two white powders together and they will hopefully react. But before I do so, I should really make sure that my container, my top here, is clean. So I'm just going to just get it a little clean here. And here I go. I'm not really good at cleaning, so I guess that's the way it goes. So I'm going to put my reaction container here, and I'm going to basically put my two little white powders together. And it's really inconsequential what they are because it's about the energy that we're talking about today in this reaction. So I want you to make good observations. So as I stir these, I want you to recognize what's happening. Okay? Look on the screen. And what can you see happening? Yeah, you can see that it's changing. It's not as solid as it may be. Again, my hands are in the way, but what do you see happening? Yeah. Yeah, what was white solid now has become like liquidy. Clearly something is going on. Did it happen in front of you? Yeah. Do you think there's a pathway for this to go? Yeah. What would you say about delta G in this case? Yeah, it definitely happened. And you may say, Mr. Grodsky, where was the activation energy? Probably the what? The room. I got some lumps here. No, I just was cleaning the board underneath it, that's all. Those two white powders, okay, were mixed together. And you saw something happen here. Clearly, there's a change. Okay? You actually can smell a little ammonia, too. So a new gas is made, but that's pretty cool that I put two white powders together and they created this slurry or this slush. I'm not getting a lot of agreement here. Yeah. Yeah. Now, would you agree this is as cool as yesterday's demo? No. Why? Well, wait a minute. Did I put a white powder in a test tube yesterday? Yeah. But I had to use a what? A blowtorch to what? Melt it. Which meant what? I needed heat or energy to force that to happen. Was that a spontaneous process at room temperature? No. I needed to add heat. That wasn't a cool reaction. I had to put a blowtorch to it. This, my friends, without any heat, I kind of melted the substance. Now, if you say to myself, Mr. Grodsky, big deal. You need to look carefully. Let's look carefully. Look up there. Look carefully. Let's look carefully. See if this is really cool. What? What just happened? What just happened, my friends, is I said it was a cool reaction. What just happened is it froze the what? It froze the water underneath it. Did I tell you it was a cool reaction? Now wait a minute. There's water on this board. Is this water normally freeze at room temperature?
No.
How did we make the water frozen? What forced the water to freeze? Where did we get the free energy to force the water to freeze? Think about it. Freezing. Is that creating order? Liquid free molecules become a solid?
Yes.
So wait a minute. If we're creating order, we're putting a lot of energy in a small place to make a solid. That's going against the universe. How are we forcing that to happen? Well, my friends in chemistry, okay? Again, it's not levitating. It looks like it's like levitating. Okay, it's stuck to the board. Okay? My friends in chemistry and bio, this is an example of a coupling of a reaction. What's a coupling of a reaction? What's a coupling of a reaction? What's a coupling? What was spontaneous?
Solid turning to liquid.
Those solids, how it changes from solid to a liquid.
Okay, yes, what was spontaneous was this reaction, which means delta G was negative or positive.
Negative.
Was it exergonic or endergonic? Has to be exergonic. This gave off free energy. The free energy that this reaction gave off was used to make the what? Water at room temperature freeze. That's what we do in biology, guys. We take energy from food. We get its what? Exergonic by catabolizing it and breaking it down. And we use that energy to do what? Build proteins or build something, make order. This is a great example of coupling that happens. Now we're going to learn the intermediate between the food that we break down catabolically to the proteins that we make anabolically. Anyone know? ATP. And that'll be a discussion for tomorrow.